Welcome class. This is our lecture series on Laplace transform, and today we are going to study about inverse Laplace transform. Laplace transform. If you would recall in our first lecture on Laplace transform, what we have studied that Laplace transform of any function f of t was our fs. So we can argue that inverse Laplace transform of f of s or Laplace inverse can be written as f of t. This is for any function. Now you must recall what derivations we have done, and I am not going to include the derivation because that is already done in the first lecture. What we studied about Laplace transform of e to the power at was 1 by s minus a, where s was greater than a. Therefore, inverse Laplace transform of s minus a is going to be e to the power 80. Now, on the same lines, we can say that the inverse Laplace of 1 by s plus a is equal to e to the power minus a of t. This is with regard to the exponential function. If you would recall, we have also studied about cos hyperbolic and sine hyperbolic. So, we will just recall the results and try to do some of them. What were the standard results? What we read? That was t to the power n was n factorial by s to the power n plus 1, where n is greater. If suppose n was greater than 0, if it was not, then it is n plus 1 factorial by s plus 1 for negative values. Also, we have studied Laplace transform of cos at was s by s to the power x square plus a square. Similarly, we have to just use the reverse. So, Laplace inverse of s by s square plus a square is equal to cos of at. So this is the s domain, and we are going to the time domain. Ideally, that is what is happening in the inverse. What was the formula for our sine? A by s square plus a square will be sine a of t. Also, you can say s by s square minus a square is equal to cos hyperbolic at. So its inverse is cos hyperbolic at. So there is no need to derive all of this because we have already done that. It is just the reverse. All we have to do is remember the standard results and solve the questions. Now I am going to take some of the question, and this question is asked in civil services examination. You have to find the Laplace inverse of 5s square plus 3s minus of 16 divided by s minus 1 s minus 2 into s plus 3. This question was asked, you have to find the inverse Laplace transform, and this is asked in 2018 IAS examination for 5 marks. So to find this is, we have to break it into partial fraction, and we have to use, so we can see the denominator, the poles are 1, 2 and minus 3. So they are unique and distinct. So what we will do, we will try to break this into constants, that is k1 by s minus 1 plus k2 by s minus 2 plus k3 by s plus 3. We have resolved into the partial fraction. If we will be able to find k1, k2 and k3 and put and take the inverse Laplace transform, we are going to get our result. So let's get started with that. To find k1, we have to put the limit k1 is equal to minus 1 5s square plus 3s 16 divided by s minus 2 into s plus 3. We could have also done it as we have done in class 12, but this is another way of writing it and it will give us results quite quickly. So if you put here 1, it becomes 5 into 1 square, that is 5 plus 3 into 1, that is 8. 5 plus 3 is 8. 8 minus 16 is minus 8. So in denominator, if you put 1 minus 2 is minus 1. 1 plus 3 is 4. So 4 into minus 1 is minus 4. So what we get as k2. Now our aim is to find k2. That is limit k tends to 2, 5s square plus 3s minus 16 divided by s minus 1 into s plus 3. So if you put here s 2 square, 5 into 4, 20, 20 plus 6, how much? 26. 26 minus 10, 16 is minus 10. Here 2 minus 1 is 1 and 2 plus 3 is 5. So that is over here we are getting as 5 and this is plus because this is 20 plus 26. 26 minus 16 is plus 10. So this results give us 2. What is k3? Limit k tends to minus 3. What we are actually doing, we are taking the poles. Poles over here is 1, here 2 and here minus 3. And we are not taking it because we have taken the limit, that is k s minus 1 and in the results we have done it. So there is no doubt about this, why we have done so. So 5s square plus 3s minus 16 s minus 1 into s minus 2. So here again if we write minus 3 into square is 9, 9 into 5 is 45, 45 minus, so we write it, this is our 45 minus 9 minus 16 divided by minus 3 minus 1 is minus 4 into minus 3 minus 2 is minus 5. So this one get cancelled. What we get, this is 16 plus 9 is 25 and 45 minus 25 is our 20. So what we get, 20 by 20, that is 1. So we have find our k1, k2, k3. Now all we have to do is write over here k1 is 2, k2 is again 2 and k3 is 1. So we have got the values. What we will do now, we will take inverse Laplace transform. So the inverse Laplace transform of this s minus 2 plus is equal to 2 e to the power t plus 2 e to the power 2t plus e to the power minus 3t. What formula we have used? We have used Laplace transform of e of at is 1 by s minus a. Here if we compare here and here, here a is 1, here if we compare a is 2 and here if we compare a is 3. So this question was asked in civil services examination in recent years, that is 2018. And what it was asking us, it was basically testing our understanding, fundamental understanding of taking the inverse.